Now we're going to try to work out a simple trick to finding out what is the trigonometric ratio for special angles. Now I'm just going to use this diagram. Hopefully that is going to be as useful as possible. Let's say this is a hand, and this is basically the left hand. And this is the last finger on the left hand. We're going to designate this as 0 degree. So this is going to be the 0. This will be the 30. This is going to be the 45. And this will be the 60. And this is going to be the 90 degree. And there is a simple trick that you could use using your left hand. So bear in mind, this is a left hand. If you have it for sine and for tangent, well, for cosine rather. If you have sine theta, the formula that you need is actually the square root of the fingers below divided by 2. And if you wanted to find the cosine theta of a star, that will be the square root of the fingers above divided by 2. Now let us start with sine. So we're going to start with sine 0. Well, that should be 0 degree. Now if we took this part and cancelled it, let us see that this is cancelled out. That is, you folded this. You need to look for the number of fingers that you would have below the 0th finger. In this case, obviously, we do not have 9. So that is going to be a 0. And so that will be square root of a 0 divided by 2. And so the square root of a 0 is actually 0. And so that will be 0 divided by 2. That should give us 0. So what that means is sine 0 is actually equal to 0. Now there is something you need to know. You need to remember this. We said that sine alpha is equal to cos 90 minus alpha. So if you were able to find the sine of an angle, you could actually find the cosine of the reciprocal angle. So if I had a sine 0, this is equal to cosine 90 minus what we called as the alpha here, which is a 0. And this is actually equal to 0. But on this side, we're going to have a cos 90. So I think I'm just going to rewrite this. So this is a sine 0, and here we're going to have a cos 90. So this is what you need to know. The value that you're going to have for sine 0, that will be equal to the value for cosine 90. So we could say that the value for cos 90 degree, that is also equal to 0. Now later on, you're going to see just how that works as we try to derive it from this method. But for now, just bear it at the back that you could have this working. This is already equal to cosine 90. Now the next stuff we want to work is a sine 30 degree. So for this sine 30, I need to cancel this or fold the finger. And so if you folded this finger, you're going to see that there is one finger below the finger of 30 degree. And the formula, of course, is square root of the fingers below divided by 2. In this case, we have a 1 as the finger which is below 30 degree. So that will be divided by 2. The square root of a 1 is basically a 1. So this will be divided by 2. And so that is basically the answer. You could write it as a 0.5 or a 1 divided by 2. Now sine 30 is equal to 0.5 or 1/2. Now if you have sine 30 equal to 1/2, what is going to be the equivalent of trigonometric function or trigonometric ratio under cosine? Sine 30 should be equal to cos 60 degree. Because basically you need to take this away from the 90 and take the cosine of that angle. That will be the same thing as cos. Well, the same thing as sine 90. Now next up, we're going to deal with sine 45. Now for sine 45, we need to cancel out that stuff. So I just need to wipe these off for now. So the fingers below, if we worked or folded 45 degrees, if we folded 45 degrees, you can see from here that there is actually two fingers below 45. So that is going to be written as a 2. This will be divided by 2. So this is actually root 2 divided by 2. That will basically be the answer. Now what is going to be the equivalent cosine angle? That will be equal to this stuff. That basically is going to be cos 45 degrees, because that should be a cos 90 minus a 45. That is going to give us a cos 45. So you need to know that cos 45 is the same thing as the square root of a 2 divided by 2. Now let us look at sine 60 degree. Now if you wipe this finger out, you're going to see that the fingers below it, that is on this side, that is actually 3. So that will be root 3 divided by 2. So basically that will be it. Now bear in mind, sine 60 is going to be the same thing as a cosine 30. How about sine 90 degree? What is that going to give? So that will be 4. So that is going to be root 4 divided by 2. And so that is a 2 divided by 2, which is equal to 1. Now this is going to be the equivalent of a cosine 0. That will give you that value. So I'm going to wipe these out. Write it out now. So this is sine 0. I'm going to start from a 0. That is equal to 0. And we have a sine 30 degree. That is equal to a half. We got sine 45 degree. That is equal to a root 2 divided by 2. And we got sine 60 degrees. That is a root 3 divided by 2. And here is a sine 90 degree. And that is a 1. Now, let us try to work cosine. So let us say we're going with, I think I'm going to start with cos 90. Now for cos, you know that should be the fingers above divided by 2 in it. So I'm going to take this. This is a 90. I'm going to wipe it out. Now you need to consider how many fingers you're going to have above 90. That is obviously 0. You don't have no fingers beyond 90 degree. So that will be a square root of a 0 divided by 2. So this is going to be 0 divided by 2. 0 divided by 2 should give us a 0. So that is going to be 0. Now you can notice from here that sine 0 is equal to cos 90 degree. So I'm just going to write that there. This is going to be cos 90 degree. Now let us try to work cos 30 or cos 60 degree rather. Now if I cancel this finger, I'm clearly going to see that from here I got one finger above 60 degree. So that should give me a root 1 divided by 2. And so that is going to be 1 divided by 2. This is a half, and that is the same thing as you have here. That is exactly what I was trying to say when I said that sine 30 will be equal to the equivalent of the complementary angle in cosine. So in this case, we're going to say that this is the same thing as cos 60 degree. Now you need to notice that there is actually a decreasing relationship between 90 degree and 60. So you could well do that on and on until you come to the final stuff. This is going to be cos 45 degrees. Here you're going to have it as a cos of 30. And here you're going to have it as a cos 0. That means a cos 0 degree is equal to this. So you just need to hold these at the back. Going to be very useful as we move on. how can you change from a radian to a degree and vice versa? How can you do it? Now let us say that you have a circle. Hopefully my circle is going to be perfect. And let's say this is the middle part of the circle. So I'm going to have the radius here and this. Now obviously we have this part as the arc. And this arc actually has a length. So let us say the length is actually the size of the radius. This is a radius, this is another radius. Now the angle which actually performs this kind of behavior is actually the radian. I need to make this red. So this is the other part. And this is actually the sector under consideration. There is an angle that this arc is actually going to subtend at the center of the circle. So let us say that angle is the angle theta. Now, as you stretch or expand this sector to a form that you have like this, until this is completely the middle part or half of a circle, we know that this is also going to be sine. So I'm just going to take this as this stuff. Now we know this is obviously going to be 180 degrees. That will be 180. Now, the length from this place to this other place is obviously going to be half of a circumference, or half of the perimeter of this circle. So this should be half of the circumference of the circle. If we actually are able to stretch this until we make it so flat, we know that this angle is going to be completely known, because that will be 180 degrees. The number of angles, or the size of the angle within a circle, is actually 360. If you divided that into 2, you're going to have 180 degrees. So we know that the angle that produces this half a circle is going to be 180 degrees. So I'm going to write this. What that means is 180 degrees is a radian that produces half of a circumference. Now, what is the formula for the circumference of a circle? That is actually 2 pi r. So this is what you got. Now, if I took this 2 and canceled into this, I'm going to have that 180 degree is equal to pi r. Now, I'm just going to leave it as a 1. This is 1 pi radian. This stuff stands for the radian. That is the angle that creates this stuff. It's called the radian. So in this case, I'm going to say 1 pi radian is going to be equal to 180 degrees. Now I can find out what 1 rad is equal to. So 1 rad is going to be equal to 180 degrees divided by pi. And the answer is actually 57 point something. I may not really remember that because I do not really have a calculator here. But if you did that, you're going to have the answer in degrees. So 1 rad is going to be approximately 57 degrees. Now, how about 1 degree? How many rads is it going to give? So I'm gonna take these out. If you have 1 pi rad is equal to 180 degree. If I divided this by 180 degree, this divided by 180 degree, I'm going to have this part to be a 1. So this is going to be a 1. And on this side, I'm going to have pi divided, that is 1 degree is equal to pi divided by 180 degree multiplied by rad. So if you can do this, that is going to be the answer to 1 degree. This should be easy. Just take out your calculator and try to find it. So from here, we can actually find out how to change angles to radians, and also to change radian angles to their degree form. So let us take some questions under it. First off, we need to establish that to change from rad, that is from radian angle, to degree, to change from radian angle to degree, you need to multiply by 180 degree divided by pi. Why is that? Because we had 1 pi rad was equal to 180 degree, right? Feel free to rewind the video and see just where we wrote that. Now, if I wanted to change from rad to degree, I'm just going to take this stuff away. So I'm going to have a 1 rad, or 1 radian, will be equal to 180 divided by pi. So that is what you need. You always need to multiply it by 180 pi. Now, just in a similar vein, you know that 1 pi rad is equal to 180 degrees. Now, if you wanted to change from degree to rad, you just need to divide through by 180 degree. So this is what you're going to have. And so obviously you will have it that 1 degree is equal to pi over 180 rad. So let us write it out. If you want to change from degree to rad, you just need to multiply by pi divided by 180 degree. So that is what you got. Now let us take some few questions. Let us say that you are required to change from, let's say 3 pi over 4 rad or radian to degrees. What is going to be the answer to it? Feel free to pause the video and try it out. Now, we know that we need to multiply 180 divided by pi to it. So this is going to be multiplied by 180 degree divided by pi. Obviously, from here, we're going to have this pi get cancelled. And we know that 4 can get into this stuff. That will be 45 times. So this should be a 45. So I'm going to have a 3 multiplied by 45. That will be 90 plus 45. 90 plus 45, that will give us 135 degrees. So this is actually the answer that you're looking for. 3/4 rads, or 3/4 pi rad rather, is equal to 135 degrees. Now let us try one more. I think I'm going to take it back in. If you have pi divided by 12, what is this going to be in degree? Feel free to try it out yourself by pausing the video and working it out. So we're going to have pi divided by 12. That will be multiplied by 180 divided by pi. So first, this is going to cancel. And then we know that if you got a 6 going into 12, that will be a 2. And if 6 goes into 180, that is going to be a 30. Now this is also going to go into 30. That will be 15 times. We know that 2 into 12 is going to be a 1. So basically, this is actually a 15 degree right there. This will be the answer. Pi divided by 12 rads is actually equal to 15 degrees. Now, there is actually an easier method to do this rather than running through the whole route. You need to know that in trigonometry, we would basically consider pi as 180 degrees. So if I had 3 pi divided by 4, you should just do it this way. This is going to be 3 multiplied by 180 divided by 4. Now I know that this is going to cancel into this and give us a 45. So 3 multiplied by 45, of course, is going to give us a 135. Now try this one by yourself. What is going to be 3 pi divided by 6? Now this is actually going to be 3 multiply by 180 divided by 6. This is going to cancel into this and give us a 30. So you're going to have a 3 multiplied by 30, which should be a 90 degree. Now bear in mind, 90 degree is the same thing as pi divided by 2. So this is basically how to work it. Now let us go on to the other one. How can you change from degree to rad? So let us say that you have a 120 degree. You wanted to change it to rad or radian. What is going to be the equivalent? Now, first I need to multiply it by pi divided by 180 degree. So I know that in this case, I'm going to have a, let us say I take a 60. If we took a 60 into 120, that should give us a 2. 60 into this should give us a 3. So this is going to be 2 multiplied by pi. And that will give us a 2 pi. And that will be divided by 3. So this will be the answer. 120 degree is equal to 2 pi divided by 3 radians. Try this one yourself. Let us say that you have a 210 degrees. What is going to be its equivalent in radian? So basically this is what you're going to have. You're going to have a 210 multiplied by pi divided by 180 degree. Now I know that I could take 30. 30 into this is going to give us a 7, and 30 into this is going to give us a 6. So that will be 7 pi divided by 6. That is going to be the final answer. So now you can see that you know how to change angles to their radian form, and also to change radian angles to their degree form.